So for question 11, we are given polynomial, cubic polynomial. When it said it has a factor, so this is our keywords. This is our keyword. When it say a factor means our polynomial will equals to 0. When it is divided by x minus 2. So x minus 2 here means our x value will equals to 2. So factor theorem said when we substitute a value inside a polynomial, if this divisor is a factor, means it will equals to 0. So if your divisor have remainder, then it will be the remainder theorem. So the difference is between equals to 0 or equals to remainder. So it said remainder 15, so the polynomial will equals to 15 when it divided by x plus 3. So our x value here is negative 3. So here they test us on factor theorem and remainder theorem. So how to write this theorem correctly? So for factor theorem, when x equals to 2, our polynomial, substitute 2 inside, it will be equals to 0. So this is our factor theorem. So this equation is our factor theorem. So for another one, remainder theorem means when we have x equals to negative 3, when we substitute it into our polynomial, we will get 15. So the difference between factor theorems and remainder theorem is factor theorems will equals to 0, remainder theorem will be equals to the numbers or the remainder they give us. So then after that only we start substitute it. So polynomial is like a function, like we do in the function. Actually you can see cubic is a function as we do it before. So polynomial is linear, quadratic, cubic, then power 4, power 5, power 6, and so on. So all those is a subpart from our function actually. So when we put a bracket 2 like this, is like a function, substitute 2 into the polynomial. It's like substitute 2 into this function. So when we substitute 2 into this function, so we want to find out what is our AB. So when we have two unknown here, normally we will have two information. Because two unknown, we will build out two equations to solve the simultaneous equation. So for the first information value of 2, when we substitute here, we will get 16. And then we will substitute the second terms here. We will get 2 squared, we will get 4a. And then we substitute here, we will get 2b minus 24 equals to 0. So we simplify this. So this is our first equation. We'll continue, move on to the second information we have. Substitute negative 3 into the polynomial, we will get negative 54. Then plus 9a minus 3b minus 24 equals to the remainder, which is 15. So we simplify it. So we have two simultaneous equations now in order to solve two unknowns. So it will like, if you have three unknowns, three simultaneous equations. You will have two unknowns, two simultaneous equations. So from the simultaneous equation part here, we will try to eliminate one of them, like this one plus b minus b. So our equation will be 1 plus 2, so that we manage to eliminate b and we can find out what is our a, 5a. So we get our a equals to 7. Then we substitute into either one of this equation. So we pick 1. So a will equal to 7, b will equal to negative 10. Therefore, what is important here, writing our theorem is very important. Writing this factor theorem, you will get 1 marks. And writing this reminder theorem, you will get 1 marks. Then only we start doing the substitution, concept of substitution of the value to get out, to solve the simultaneous equation until we get this answer, A and B. Okay, we continue part B, factorize our polynomial completely and hence find its zero. So when we want to factorize the polynomial completely, we divide our polynomial with our factor. So our factor here is x minus 2. So when we divide it with our factor, we can get others factor. So this polynomial, you can see it is cubic polynomial, means normally you will have 3 factors, 3 linear factors. So from the factors only we can find out the roots, because this is the form in the factor x plus something. Let's say x plus a, x plus b, x plus c, that's our factors. From this factor we get roots, x equals to a, x equals to b, x equals to c. So from the roots only we can take out the value that a, b, c are zeros. So just mathematical terms that differentiate the form of the answer, but they are coming from the same resource here. So how we go to finding the factor? So we take our polynomial here, where our polynomial here is 2x cubed, where a is 7, x squared, and then minus 10x minus 24. Divide it, we do long division, divide it with its factors. So we will divide it with this factor in order to get other factors here. So how to do long division? So we have to find the multiplier here, which when we find this multiplier, we multiply with this x, we can cancel the first term here, 2x cubed. So what is the value we need here? We can do the division. 2 divided by 1, we need a value of 2. X cubed divided by x, we need a value of x squared. Then we expand back. 2x squared times x, 2x cubed. And then expand for the following term, 2 times 2 here, negative 4x squared. Then we minus, we can see we can eliminate, we can cancel the first term already. 2 minus 2, 0, so 7 minus negative 4, it will become positive. So it equals to 11x squared. So the rest of it just pull down. Then we repeat. We repeat until our balance here, the ranking is smaller than linear, because our polynomial is followed by ranking. By first ranking, the smallest one is a constant, no x, then continue linear power 1, continue quadratic power 2, continue power 3. So you can see here quadratic is still bigger than linear. So we still can do the division. We proceed the division. What's the value we need here is 11. So I need another x. So that when I do the multiply here, so the multiplier here is 11x. When I do the multiply here, I can cancel the 11x squared. The terms at the back, we just expand, follow it. So 11 times 2, 22. And we minus. So when we minus, here getting 0. So here when we minus, it positive, it will become 12x. So we continue, you can see now it's linear over linear. So still can do the division until the remainder is smaller than your divisor. So what is the multiplier we need here is 12. So when we have 12 times x, I can get 12x. So this first term can be eliminated. Then the following terms we will expand like usual. So you'll notice that when we divide with our factor, we won't have any reminder 0. We have 0. So that's why when we doing our reminder theorem, we will put equals to 0 because it don't have any reminder actually. So if you're not doing factors, if this is not factor, means if you divide by this, you will get your reminder 15 at the back, at the down here, the last part here. So reminder theorem, that's why they put equals to 0. So how to write this? This will equals to polynomial equals to our divisor x minus 2, our quotient 2x squared plus 11x plus 12, and plus reminder. So reminder we don't have. So actually our original writing is like this. When a polynomial divide with a divisor, you will get a quotient plus reminder over a divisor. So this is the writing form in fraction. This is a writing form in fraction. If I don't want to writing form in fraction, I want to get an equation, so I will times the x. So this is a writing form in sentence one line here. So here is our polynomial. What's your divisor? Your divisor is this. Quotient is this. So reminder I don't have. So our polynomial now from the expanding format now already written in factor format. So put in bracket means already in factor format. So we haven't finished factorize it because quadratic still can undergo factorize. So we express it, factorize it completely. So for quadratic part, we factorize, we can use our calculator like usual. Put in your A is 2, B is 11, C is 12. We find out, then we put in the bracket 2x plus 3 and then x plus 4. So this is what we mean by the question, factorize it completely. So cubic will have 3 factors of the linear because you can see x, you get back to x cubed. So from the factor, then we proceed, we see what is the value of x, then take the value, it will be our zeros. So we can read here, x is equals to 2, x is negative 3 over 2, x is negative 4. So this is what we call roots. This is what we call factor in bracket. So zeros means the value on it, we want the value on it. So zeros are the value of 2, the value of negative 3 over 2, and then the value of negative 4. So from here, for concept of long division, and then to get this quotient, writing in factor form, and then factorize it completely where the quadratic also need to factorize. And then lastly, we answer the question we want the zeros. So this zeros is our final answer.